Okay, we are off to chapter 6. This is actually one of my favorite sections. Might seem a little weird to most of you guys at first, but it talks about what if you want to solve more than one linear equation at once. And honestly, you have done this already because you have found break-even points, right? And that's what this is doing. But as you're going to see, there may not be an actual break-even point, okay, where the line intersects at one point. There could be something where there's infinitely many points. You may not be able to tell it, but there is a blue and a red line there. If you look here, you can see one is just 2 times the other. And then you could have parallel lines where they never intersect. So there's lots of use of these, as you're going to see, as well as these growing larger. And by larger, I mean what you saw here are 2 equations with 2 variables, right? X and Y are your 2 variables. Well, we can get into even larger ones, and we need a way to be able to solve these because it even gets difficult if you have 3 equations, 3 variables. That's 3 dimensions that we're thinking of, where this is graphing in 2 dimensions, which most of us are okay with. So we need a technique, as you're going to see in this section, to go through and how to actually solve these. We do these by different operations to be able to solve these systems. And it's important once you learn these, first how to set these up. You're going to see we're going to use matrices, kind of like the cool movie, The Matrix. Well, maybe not that cool, but what we do is we take just the coefficients, the numbers, and we put them in this matrix. And I will tell you the reason why we do this is it makes it easy for a computer to solve. Okay, but we're going to make you solve it, right? And you'll see we'll go through different operations, such as I might say take 1/2 of row 1. And as long as you do the same thing, that's where your brain has to go, oh, well, if I divided every term by 2, I can do that because it's an equation. And so there'll be these various row operations that we're going to do, and we try to get to a point where we can solve these equations. Okay, and this is showing this one cannot be solved. And then we'll continue to do these with, of course, applications of who would even use this. Very good applications that we will actually work through in the course. I'll just kind of show you this example here of, the population. This is a quadratic, but once again, you can have more than one equation. And so I'm just going to flip through the solutions because I will actually work these by hand. And it does say use technology, but we are going to do these actually by hand to show how to work these out step by step. And the whole key, as you're going to see, is going to be putting these to begin with in these matrices. And then we'll see that we can actually do some operations on matrices. You can add matrices together, you can subtract matrices, and we simply do this by making sure we're, like if you notice that I am in the same spot, the placement of what I'm adding, and to get a different matrices. I can see that if I have different sizes, I cannot add these because they have to be the same size. All right, we can of course subtract matrices. We can do scalar multiplication, which is multiplying a value by a matrices. This actually happens a lot in video games where you can see something is enlarging. Matrices are big use in computer science. We can take the negative of a matrices, and you're going to see all these different common properties that we can use for matrices. Okay, so once again, adding, associative. You could probably see these are properties that we've used already in math. We just can also use them with matrices. And then we're going to look at how we can use inverses of a matrix to be able to solve various problems. And as you can see here, we can also multiply, and we have our associative and distributed again, as you've used in algebra, no difference there. And then we have to make sure that we can actually multiply these. So we'll look at, once again, the number of rows versus the number of columns. And as I mentioned, we'll figure out what's the big deal with an inverse matrix and actually can be used to solve some applications. And then that's where we'll end up with using these to solve applications. So that's just kind of an overview. No problems worked yet. We're going to go straight, into the problems and just try to see where this material is even being used in the real world.